This is Mike Neary, Extension Small Ruminant Specialist at Purdue University. I'd like to welcome you to the 2019 Sheep and Goat webinar, sponsored by Purdue University and Kentucky State University. We're very glad you can join us, and hopefully tonight's program is educational. I'd like to thank the Program Planning Committee for all their work on putting on this webinar. That includes Dr. Ken Andrews from Kentucky State University, Mark Kepler, Extension Educator, Fulton County, Indiana, Sarah Zamansky, Extension Educator, Perry County, Indiana, Alicia Rogers, Extension Educator, DeKalb County, Indiana, Phil Reed, Distance Education Coordinator, Purdue University, Dr. Scott Radcliffe, Professor, Animal Sciences, Purdue University. A few housekeeping items before we get started. Number one, we will take a short break, about 5 minutes, at the conclusion of each presentation. This will allow time for any questions to get submitted and allow us some time to sort through and organize them. Secondly, we really do encourage questions. Just submit them in the chat room, which is located on the main page where you logged in to. You can actually have the chat room and presentation open at the same time in two different tabs of your browser. Thirdly, the program will be recorded and put up on YouTube for later viewing. It will take about a week or so to get the editing done. Once it is done, we will announce on the Purdue Sheep and Goat Extension Facebook page when it's ready for viewing. You also may be able to search YouTube for it. And then lastly, please evaluate the program. The evaluation is available for home viewers on the main page where you logged on. Those of you at viewing stations will receive your own paper evaluations. We really do value your input, and our goal is to make these webinars as educational as possible. Especially make comments and give suggestions on ideas for future webinar topics that are associated with sheep and goats. Our first presenter is Alicia Rogers. Alicia has been the Ag and Natural Resource Educator with Purdue Extension in DeKalb County, Indiana, for about 10 years. She has a background in forages from Michigan State University, and her husband also raise boar and dairy goats in their spare time. Alicia will discuss the topic, AI, mating without the male.
Go ahead.
All right, so good evening, everybody. I'm Alicia Rogers, and I'll be your first presenter this evening. And I'm going to be talking to you guys about artificial insemination. So we talk about mating without the male today. So get it going here. All right. So when we talk about artificial insemination, a lot of times you'll see the initials AI. Doesn't mean artificial intelligence in this case. Sometimes it gets a little confusing, but we're going to talk about artificial insemination when we're referring to AI tonight. So to start with, artificial insemination is just very simply the introduction of sperm in the female reproductive tract by means of an instrument. So you're not using a live animal to do that mating. It's really the oldest technique in assisted reproduction. So that means you're helping getting that breeding done. It really came on strong in the cattle and dairy industry first, and it's just starting to gain traction in the sheep and goat industry, especially when you look at the dairy goat and the boar goat industry. So the use of artificial insemination in animal reproduction was originally used pretty much for sanitary reasons. So when you think of biosecurity, especially, if you have less animals on the farm, less animals that you're bringing in and taking out, there's less chance of disease, illnesses, things like that that can spread with that movement of those animals. So if you can reduce that by just having straws of semen available, it can greatly increase the biosecurity on your facility. Um, but with that, the farmers soon recognized that artificial insemination was the method of choice for really quick introduction of valuable genes into that population to improve the production traits. So basically meaning that it was a great way to introduce strong genes without having to pay the cost for it, without having to pay the cost for the live animal. So pros, insemination, increased rate of genetic improvement. So basically, you're getting that higher quality breeding without having to have the actual animal. The introduction of rare or expensive genetics. So if you're looking at something like the boar goat side of the industry, they've only been in the United States since 1993. But if you want to go back to some of those original genetics that came over from Africa, it's fairly easy to do so, even though it's 25, 26 years old. You can still get straws from some of those original animals to use in your herds. There's no cost for the buck maintenance. That's what my husband and I have dairy goats and boar goats. Currently, we have, trying to remember, 6 or 8, I think it's 8 bucks on the property. They can be a little destructive. So if we didn't have to pay for repairing fences or the upkeep of those animals, the feed costs, things like that, it's a great benefit. And then
Alicia,
predetermined, yes.
I hate to butt in here, but we're getting a little feedback. So do you have the live stream open on your end by any chance?
I do not.
Okay, then somebody else. Sorry about that.
Okay, not a problem. So, all right, and then you get predetermined kitting dates. So you know when you inject that semen into that female, you have a pretty good idea of when those kids or those lambs are going to come out.
Alicia,
Instead of if you
I
do
hate to
group
butt in here,
breedings,
but we're getting
kind
a
of
little
having a
feedback.
rough
So do you have the
estimate.
live stream open on your end by any chance?
Some of the cons or some of the
Okay, then somebody
negatives
else.
of
Sorry about
artificial
that.
insemination, requiring facilities. So if you're going to be doing the collecting of the buck and things like that yourself, you're going to have to require a little bit of kind of some different handling facilities, things like that when you're going through this. Requires expertise. So depending on which method of artificial insemination you use, depends on what kind of training you or your vet need to have to make it successful. And then requires multiple handling of animals. So on the buck side, you have to handle the buck, you have to collect the semen from him, and then on the doe or ewe side, you have to potentially, you'll have to handle her for the breeding itself. If you're doing a synced breeding, you'll have to handle her when you're doing different hormones, things like that. So there's a lot more handling that you might have to do on the animals um, than not. So we're going to get started just kind of looking at kind of that reproductive anatomy of both the male and the female side, so you can kind of understand how the process works. So to start with, on our male reproductive anatomy, we're going to start with the testes. So basically the male gonad, it's the site of where that sperm production takes place. It's where that sperm starts. It's basically manufactured. It's also the site of the testosterone production. So if you have a male with a lot of testosterone, chances are he's going to have a little bit larger gonads. Next region that you see here is the epididymis. And so that connects the testicle to what's called the vas deferens that we'll talk about here in a second. So the epididymis is made up of the head, the body, and the tail. So you can see here, this is the head down here. The body is in between. Nope, sorry. The head, the body, and then the tail here kind of comes off of it. So it's also responsible for sperm cell storage. So once the testicles produce that sperm, it's stored there until it's moved on for sperm maturation. So this is where the sperm really grow and mature into, hopefully, productive citizens, productive sperm, and also increase in concentration. So that's where the storage comes into play. It's where this sperm is gathered. So the more sperm there is, the better chance of that natural or artificial insemination. Next up is our scrotum. So you see this a lot of times, like in Australia, they'll have kangaroo scrotum pouches, things like that. So it's literally just the protective covering of that testicle. Um, Nothing more than that. Helps to aid in temperature regulation. So this helps keep everything cool and regulated in that area. Next up is our vas deferens. And so it's this tube here. It connects the epididymis to the accessory sex glands that we can see up here to the top. This is a portion that's removed during a vasectomy on any male. So you can actually have vasectomies on livestock. This is how you get some teaser bucks on both the goat and the sheep side. So if you are doing artificial insemination, a teaser buck is a great, I guess you could say, accessory to have on your farm or available to you. He can certainly, if he's bred before, he certainly knows what he's doing. He can tell you a lot easier when the doe is in a standing heat, but there should, in theory, if the vasectomy is done correctly, not be any result of any breeding attempts. All right, next we have our accessory sex glands. So these are the areas that secrete buffers. They're an energy source for that sperm, and they contribute to the semen volume. So basically what that means is when the semen's ejaculated, you have the sperm itself, and then you have the different liquids, the proteins that come with that sperm. So that's where this all combines together in these accessory sex glands. So you get the sperm mixing with the seminal fluids, things like that. So this is made up of what's called the ampulla, the prostate, the seminal vesicles, and the bulbourethral glands. I had to practice that a few times. Bulbourethral glands. So that makes up our accessory sex glands. Next up is our sigmoid flexure, and it's a muscle inside the male animals. And it's the muscle that straightens during the erection. So it's what pushes that penis out of that animal. And then on the opposite side, we have the retractor penis muscle. So again, it's a muscle. You can see it here in green. And this is what relaxes during an erection. So with the sigmoid flexure pushing out, the retractor penis relaxes. And so when that copulation or reproduction is done, the retractor penis muscle tightens up and pulls that penis back in. And then the last portion of our male reproductive anatomy today is obviously the penis. So it's the copulatory organ. It's where the sperm, the seminal fluids, everything comes out, either gets collected or is directly inserted into the female. So it's just a broad overview of the male reproductive anatomy. Maybe a little bit more than you want to know, but it helps us understand kind of that sperm process and how it gets to the outside. So when we're looking at male sperm characteristics, there are a few things we want to look at, especially if we're collecting that animal and how much we want for viable sperm, and especially if they're going to be frozen and put into straws. So ideally, you'd like about a milliliter of basically volume of your sperm, your semen, per straw. Milliliters, not that much, but within that milliliter, you're looking at about 4 billion sperm on average. It can be anywhere from 2 to 5 for a good count, but you want at least about 4 billion for good, especially if it's going to be frozen semen. You want, when you're looking at that 4 billion semen or sperm, you want about 80% of them to be motile. So that means you want to see them moving about. If you see some that are just sitting there not doing a whole lot, you aren't going to get any successful breedings out of those. So you want good movement of those sperm as they move through that seminal fluid. And then of those 80% of the motile sperm, you want 80% of those to be what they call morphologically normal. So that means they aren't going to have crooked tails. There's not going to be any divots in the head of the sperm. It means they're going to have a much better chance of actually doing that breeding and making that connection and causing those kids or lambs to be formed. So when we're looking at motility itself, motility, like I said, is the movement of that sperm through that seminal plasma, so through that liquid that it's contained in. The total motility is the complete sperm, so the complete package, how it moves through the seminal plasma, and then the progressive motility, so just the forward movement of that sperm. So the sperm may be moving sideways, that would still be considered total motility, but if it's not moving forward and moving toward that goal of that egg, it's not going to be beneficial. So for semen analysis, obviously once the buck is collected, the samples are analyzed for what they call pre-freeze motility. So how are the sperm moving before they're put into liquid nitrogen? So very simple, is just put on a slide, put under a microscope, and those sperm are just analyzed. Anybody should be able to do that, especially once you get the idea and know what you're looking at. So these are a few semen abnormalities that that can show up. So we can see just different types of abnormalities. You can see the head here is kind of flat and divoted. B here, a little bit elongated. You've got kind of a bump here on the tail. Same with C. D, kind of an egg shape almost to it. E, you can see the crooked tail. Same with J, very crooked and twisted. And I. H doesn't have a tail at all, so he's not going to be mobile at all. It's just going to be a speck. G kind of has some weird divots. Same with F. K has some really kind of odd tail fixtures going on. L has the weird bump. And so it just kind of goes on like that. So if you see abnormalities like this going on, there's a good chance if you have more of this than regular sperm, that your breeding might not be as successful, especially if you're going to freeze that semen. So important thing, if you do freeze the semen and then you go to thaw it, you want that semen to kind of come out, not gradually, but you want it to be maintained at kind of a constant temperature once it's thawed. Semen is very delicate to changes in temperatures, especially huge swings. We'll see in a moment when it's down in a semen tank, you're looking at about negative 320 degrees Fahrenheit. So when you're going from that to our thaw containers here, you want those to be steady at about 95 to 98 degrees. So fairly close to our body temperature. And that just kind of gets that semen woken back up, gets them moving, gets them active, but doesn't overcook them. But you're still looking at an almost 400, 420 degree swing in temperatures. If you thought the 100-degree swings we had 10 days ago here in Indiana was bad, imagine 4 times that. So when we're looking at semen freezing, typically your best results if you're going to freeze your semen are going to be during the natural breeding season. So kind of in the fall, maybe late, about now would be about as long as you might be able to get through it, just because that's when they're naturally breeding. It's when the semen's at the best kind of production. You're not forcing them to kind of breed out of season. So you're going to have probably the best quality semen that you're going to be able to get during the natural breeding season. You're definitely going to have variability year to year, buck to buck. So in season, out of season, definitely makes a difference. So if you're trying to collect your buck, so ram or buck, sorry, I'm used to goats, so I keep saying bucks. So if you're trying to collect your male, we'll say that, out of season, you're going to see an increase in seminal seminal plasma proteins. So basically that other liquid that's surrounding that sperm, just because it's not natural for it to be produced kind of out of season, out of that breeding season. So it just makes it a lot thicker, and you're going to have more of that instead of your sperm concentrate. Again, the individual animal, that buck itself, is definitely going to make a difference on how much semen can be collected. If he's had a fever anywhere in the last 6 months, that could definitely have a huge impact on the quality and amount of semen collected. If back in May he came down with something and had a fever, that can definitely affect the testicles. It can affect the sperm count, um, everything along those lines. So if you are finding that it seems like your male is just shooting blanks per se, you may want to get him collected just to see what's going on with that semen. Um, we had a friend that had a buck collected. He hadn't been doing well all fall. They just wanted to get him collected just to see if they could get some semen out of him, and they couldn't find any viable semen just because of the fever and everything that he'd undergone. Um, so sometimes they can come out of it after a few months. Other times, it completely kills the reproductive skill, basically kills the sperm, um, and any future sperm it may produce. So things to watch out for there. And then occasionally, semen collectors may put what's called extenders in mixed with the semen, the sperm. Could be things like egg yolk or a non-animal protein. It just helps kind of provide a little bit more fluid in those canes. Usually not really any effect on the sperm itself, but just be aware. So, all right, so when we're looking at kind of our post-thaw semen evaluation, so once your semen's been frozen and it's being thawed before you insert it into the female, you kind of might want to take a look at it just to see if it survived the freeze. So like I said, semen sensitive to temperature change, mainly decreasing temperatures. So when it's going from body heat, body temperature, from being inside that male into the canes and then into the liquid nitrogen, it definitely goes through a shock. So sometimes that can destroy that sperm if it's not careful. You also need to be aware of your environment when you're thawing the semen. So if you're thawing in your barn, a climate controlled building, anything like that, you want to try to keep it basically, like I said, between the 95 and 98 degrees if possible. So if you're breeding late fall, so August, September timeframe, when the days are still a little bit warm, it's not such a big deal. But if you're trying to get a doe or a ewe AI'd right now, that's when the temperature swings make a huge difference. So if you're trying to do it right now, what you can do is thaw your semen in the house where it's warmer, stick it in the gun, and then put it next to your skin, carry it out to the barn, have that doe or ewe ready to go, and breed her right then and there. If you wait too long, you could have some freezing, temperatures lowered, things like that can cause some adverse effects. So if you are going to be doing an assessment before you breed the female, you do want a slide warmer, just for an accurate assessment, just so you can keep it at that steady temperature, 95 to 98 degrees. It's just slides. You put them on this slide warmer that we see here, just so those glass slides are warmed up. And then you can squirt the semen on there a little bit, inspect it, make sure it's good, and you're good to go. So, for example, this is going to be a semen report that we're going to look at. We're going to look at a couple of them. So after collection, this is what this particular collection agency saw. So they collected, on average, what they could get per straw, about 3/4 of a milliliter of semen volume. That's acceptable. It's between the half and the 1.5 milliliters that they recommend. The motility, however, was only at about 45%, and you can see that right here. So ideally, you want it between about 70 and 90%. Automatically, this is kind of a red flag. May not be the best option for freezing your semen. Concentration was still good at about 3 billion count, and morphology, so how much of that motile sperm was morphologically correct, is about 80%. So you're only looking at about maybe 40, 38, 40% of your sperm actually being morphologically correct to get that breeding done. Not exactly a good candidate for freezing when you're starting out that low. However, when you look at our second buck here, they have on average a milliliter of semen volume, 90% motility, great for semen collection, about 5 billion sperm per milliliter, really good swimmers here, and then about 90% morphologically correct. So he is a great candidate for freezing. Barring any issues with the freeze tank itself, these should come out pretty good and ready to go. So when we're talking about our semen handling, you can see here the varying depths and varying temperatures in a semen tank. It doesn't matter how big or how small the semen tank is going to be. It's going to be about the same temperatures when you look at different lengths. So we're looking at about a 6-inch head here. So you've got the top of the tank here and go about 6 inches down. That's going to be the difference of about 54 degrees Fahrenheit down to almost 300 degrees negative Fahrenheit. That's a huge change really quick as you're putting that cane down into that liquid nitrogen. When you're bringing that sperm back up, holding that whole goblet, the cane, things like that, up above this frost line for even more than a few seconds can cause that sperm to start to thaw, and when you put it back in, they're going to refreeze. As I always say, when you're freezing and refreezing meats and fruits and things like that, you don't want to pull it out, thaw it, and then put it back in. Same with your semen. You want to use it if it's going to be out. So when you're looking at your correct semen handling and transferring, obviously you want to maintain your semen quality to the best of your abilities. Semen straws have a very, very small surface area. If you can picture a coffee straw, coffee stir, that's about the same size as your semen straw. Not a lot of surface area, warms up very quickly. So when you're transferring semen from tank to tank or tank to your warming thermos, things like that, you want to do it quickly so it can get the right temperatures and stay at the right temperatures. So that's kind of our semen collection. So now we're going to look real quick at our female reproductive anatomy so you can kind of see the female end of it. So we're going to start here with our vulva. So this is the external genitalia. So we're starting from the outside and going in on the female. So this provides the opening to the vagina. It's just right there. Next up is the vagina itself. So this is located between the vulva and what they call the cervix. And this is usually the site of the semen deposition during your natural mating. So when you have your buck or your ram, this right in here is where that semen is going to be deposited. Next up, we have our cervix, which is back here. It's kind of the pink squiggly thing. So this is between the vagina and the uterine body. And this is a lot of dense connective tissue, folds, things like that. Helps to protect the uterus from anything external. Farther back we go in, we get to the uterus. This is made up of the uterine body and the uterine horns. So normal female will have 2 horns connected to the body. You can see that here. Kind of almost looks like a ram's head. So you've got kind of the head with the horns. Next up, we have the oviduct. That's going to be at the end of the horns. And this is where the sperm actually meets the egg. So during natural mating, the sperm has to go from the vagina, through the cervix, through the uterine body, through the uterine horns, and finally make it to the oviduct. So that's why you want to have good motility, good morphology, so they can make that straight beeline to their target of the egg. And then lastly, we have the ovary, just kind of hanging out here on the very end. This is the location of all the eggs the female is going to have in her lifetime. It's also where the hormones are produced, including progesterone and estrogen. So we'll talk about those here just a second. So the ovary communicates via hormones with the brain. So it tells that female when to go into heat and when to come out of heat, if they've been bred or if they need to go back into heat. So the brain produces what's called a follicle stimulating hormone and a luteinizing hormone. And we'll get into that in just a second. So this is an example of an estrus cycle. I use goats just because that's what I'm most familiar with, but it's very similar to sheep, just a little bit shortened. So we have here at day 0, we have what's called the estrus, which is day 0. This is when they would be in what you could call standing heat. So you can see here the LH, that's our luteinizing hormone. That's really escalated right here along with our estrogen counts. So it's just telling that female to go into heat. Next is metastrus, which are days 1 to 4. This is where our progesterone counts start to rise. Diestrus is going to be about days 5 to 16. This is the period in which the female body decides if it's bred or not. If that fertilization has occurred, then she goes on and hopefully carries that young until it's born. If not, starts producing this chemical called prostaglandin. So basically that causes that egg to be released because it hasn't been fertilized, and day 17 to 21 she goes into proestrus. So when that egg's released, that prostaglandin is produced and it causes the estrogen, follicle stimulating hormone, luteinizing hormone, all those to ramp back up into production to go back into heat. So real quick, the hormones and what they do are estrogen, like we said, induces the estrus. It's the growth of that follicle in in our uterine horns, things like that. So the progesterone, that big red line, stimulates and maintains what's called the corpus luteum, and we'll look at that in just a second. The luteinizing hormone is the final maturation of the follicle on the corpus luteum. Ovulation of that follicle, so if it takes place, that luteinizing hormone's there to help it, and it also forms the corpus luteums. The prostaglandin basically stimulates the release of our luteinizing hormone if there's no pregnancy there. And then the follicle stimulating hormone basically stimulates our follicles. So when I talk about follicles, you can see they're these kind of lumps here. They're located there near our ovaries. And basically these are the sites of where the egg production takes place. So we have here in our red box, this is our standing heat. This is what that follicle would look like. So it's got this huge lump on the end. That's our corpus luteum. And so that's basically where the egg is going to be. Here we've got about day 6. You can see it here. About day 8, it's located here. Day 12, this one happened to not be fertilized. So you can see it's gone from an angry red to being reabsorbed back into that follicle. You can see that here. And then by day 18, it's almost like it wasn't there. So it's being reabsorbed back into the follicle because it wasn't fertilized. So when we're looking at the estrus cycle of goats, normal length is going to be about 21 days. Duration of your estrus when they're going to be in that standing heat is going to be about 30 hours. Granted, it can be as short as 16 or as long as 50. Sheep, on the other hand, have an average cycle length of about 17 days. Duration of estrus is going to be the same, about 30 hours, anywhere from 16 to 50. So those are things to keep in mind when you're AIing, is how long that estrus cycle is if you're watching them to do a natural breeding, natural cycle instead of using hormones. So these are kind of some of our key factors to success. I'll kind of go over them briefly, and then we have a video explaining it a little bit more. So kind of the 5 factors that we have to our success are going to be technical experience, seasonality, age, nutritional management, and then our semen quality. So Scott, if you would go ahead and play that video for us.
It is always exciting to have a successful breeding if you artificially inseminate your own sheep or goats. Let's take a look at each of the key factors that lead to the success of your AI techniques. They are technical experience, seasonality, age, nutritional management, and semen quality. The first key is technical experience of the person performing the artificial insemination. No matter which method you use for AI, having the practice and technique will help you make sure you, your vet, or AI specialist have a doe or ewe that settles. Vaginal, cervical, and transcervical artificial insemination can easily be learned, but laparoscopic should be done by a vet or veterinary trained individual. The time of the year can also lead to success or failure of your artificial insemination. AIing during the natural breeding cycle, when the light begins to shorten in the fall, is one way to breed. If you want to breed out of season or have synchronized breedings of several females, you will need to use hormones. A combination of cedars, PG600, and luteolase are usually recommended to bring your female into estrus during the off-season.
The package directions state that the cedar device should be removed after 5 days. There is research to support this 5-day protocol. However, some producers and researchers have found success using a longer 10 to 12-day protocol for sheep or 14-day protocol for goats. Consider these suggested protocols as guidelines and use whichever works best for your operation.
The age of the animal will also have an effect on how successful your artificial insemination attempt will be. A first breeding female or an older female will have less chance of successfully settling the AI techniques. To help determine the age of your small ruminant female, this following video from the National Center for Appropriate Technology shows the proper tooth readings.
You can tell how old a sheep or goat is by looking at their teeth. Sheep and goats do not have upper front teeth. Instead, they have a hard dental pad on the upper jaw. There are 4 pairs of incisor teeth on the lower front jaw. Like humans, they start with baby teeth, and each year they get a new set of permanent teeth. So you can determine their age based on the number of sets of permanent teeth. To age a sheep or goat, have someone holding the animal or have it restrained. You pull the lips apart to examine the teeth. Here we have a goat under a year of age. You can see that all of the teeth are similar in size. Here we have a 1-year-old animal. You can see the first permanent set of teeth. They are larger than the baby teeth. This animal has 3 sets of permanent teeth, so it is a 3-year-old. At 4 years of age, they will have all 4 sets of their permanent teeth. After age 4, you can estimate an animal's age based on the wear and tear of the teeth. Here you can see some chips out of the teeth, indicating wear. If the teeth are more spread out, are worn down, or are missing, then you know it is an older animal. Knowing how to age sheep and goats is useful when purchasing animals. If you know how old an animal is, you can estimate how many more productive years it has.
Another major factor we look at when artificially inseminating small ruminants is the overall nutrition and appearance of your breeding female. Proper feeding and body weight throughout the breeding and pregnancy of your herd. Purdue University produced the following video that highlights what to look for in body condition scoring used with small ruminants and the proper weights for breeding and pregnancy.
A score of 1 is an emaciated sheep. The spinous processes are very prominent and can be easily felt. On the loin, there is little muscle and no fat. The transverse processes can also be easily felt, and one can pass fingers underneath them. Sheep at this score are more prone to disease and have a higher risk of death. If you have a sheep with a score of 1, you should evaluate your feeding programs, check for parasites, and check the teeth of the sheep. These could be the reasons the sheep is underweight. If not, it could also be from age or more serious health problems. A score of 2 is a thin sheep. The spinous processes are still prominent, but the loin is filled with more muscle with little fat cover. The transverse processes are rounder, and slight pressure is needed to feel underneath them. A score of 3 is an average sheep. The spinous processes are smooth and round, and individual processes can only be felt if pressure is applied. The loin has a full amount of muscle with some fat cover. The transverse processes are smooth and firm pressure is needed to feel them. A score of 4 is a fat sheep. The spinous processes are hard to feel and can only be felt with some pressure. The loin has a full amount of muscle and a large amount of fat. The transverse processes cannot be felt. A score of 5 is an obese sheep. The spinous processes cannot be felt. The loin has a full amount of muscle and a thick covering of fat. The transverse processes cannot be felt. A score of 5 is not a good thing, as they are too fat and are not fit. Overweight sheep are more prone to lambing problems and prolapses.
The last success factor we will discuss when artificially inseminating your small ruminant females is the semen itself. This plays one of the largest roles in the actual breeding program as any other success factor we have talked about in this video. Semen motility is viewed under a microscope when the male is collected to determine if they are a good candidate for artificial insemination, especially if the semen is going to be frozen before use. This video from the University of Sydney's Animal Reproduction Group shows a semen mass sample with a score of 0 out of 5, meaning it's not viable. This video shows semen with a mass motility score of 5 out of 5. This sample would be great for freezing and then using with proper thaw techniques. In summary, our 5 key factors to a successful small ruminant artificial insemination include technical experience, seasonality, age of the female, nutritional management, and semen quality.
Over to you.
Okay. All right. So you've looked at kind of what those key success factors are when we're looking at artificially inseminating our does or our ewes. So we're going to take a look now at the actual artificial insemination processes. There are 4 we're going to look at. The first is going to be the vaginal artificial insemination. So this is basically the simplest form of insemination out there. Basically, you're depositing semen right into the anterior vagina without any attempt to locate the cervix. So you're just kind of popping it right in there, not really trying to go any deeper. Reported success rates are really variable with this, and it's not really suitable for frozen semen just because the fresh semen obviously is going to be fresher. It hasn't gone through that freezing process, and so it's going to have a little more, I guess you could say, energy to it. It hasn't gone through that freezing and thawing process, so it's going to be fresh and better to use. Next process is going to be the cervical artificial insemination. So this is another what they refer to as cheap and relatively easy method of insemination. So basically you locate the cervix via speculum. So it's just a little plastic tube that gets inserted, fitted with a light so you can see what's in there, what's going on. And the semen's deposited into about the first fold of that cervix. You saw how it had a bunch of ridges in it. So you're just going to go in just basically to the first point, just into that cervix to deposit the semen in this case. Conception rates are good with fresh or chilled semen, but usually what the industry refers to as unacceptably low with frozen and thawed semen. So you can take that semen and you can kind of chill it down, kind of refrigerate it if you need to move it to another location. And it works okay with the cervical. But if you're going to freeze it and then thaw it, it's not going to work quite as well. So equipment needed for both cervical and our next one, which will be transcervical. Liquid nitrogen tank, obviously to hold your semen. Speculums, large and small. And you can see that that's kind of this tube right here. An AI light, which you can see right here, just a little pin flashlight. Straw tweezers here. So you can grab that cane out of the goblet, or that straw out of the cane in the goblet. Sterile lube. So you want to make sure that it's not a non-spermicidal lube. If you have spermicidal lube, it's going to kill your sperm. So you want to make sure it's a sterile lube. your actual insemination gun, which I forgot to get a picture of, but it's just a long metal tube, a breeding stand or some way to hold that female without a lot of arms available, the thaw box, which we can kind of see back here, and it'll keep that semen at a pretty constant temperature of 95 to 98 degrees. Paper towels. It does get a little bit messy and a little bit gooey, so you have something to wipe down with. The straw cutter that you can see here, so you can snip off the end of that straw and get the semen out. And then a thermometer, so you can keep track of your temperature in your thaw box and go from there. So when we're looking at actual kidding rates in relation to the depth of that semen deposition in the cervix, when you're looking at kind of difference between fresh and frozen, you can see that on the chart here. So when you're barely getting it into that cervix, that first centimeter, you're going to have about 42% success rate with fresh, 27% with frozen. If you get 1 to 3 centimeters in, you're going to have quite a bit higher rate, about 58% with fresh, 46% with frozen, so almost 20% more. And if you actually get it through the cervix and back into that uterus, you're going to have about 69% success rate with fresh or frozen. So the farther in you can get that semen, the higher the success rate you're going to have with your insemination. So like I said, our third method here is our transcervical artificial insemination. This is where you go in with your speculum, you locate your cervix, and you use your gun and you insert it past the cervix into the body of the uterus. So on goats, it's basically going to be, you kind of have to wiggle it through, but it's going to be about 3 successive pops. So you're going to kind of have it go pop, 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 and then you're going to be into the uterus. It's going to be very similar on sheep. Most of our small ruminants have very similar cervixes. So you want to make sure that you get into that uterus. Like we saw, higher conception rates than vaginal or just regular cervical. This is a method that you can get trained on, anywhere from watching YouTube videos to actually attending hands-on trainings by professionals. And then our last type is going to be the laparoscopic artificial insemination. So this is also referred to as intrauterine. So this is actually going straight into the uterus. You bypass the cervix, deposits the semen directly into the uterine horns, so where it hooks around. It's actually developed by Australian researchers in 1982, primarily for use on sheep is where they were using it. It is actually a minimally invasive surgical procedure, so you do, in theory, should have veterinary expertise when you're doing it. Either be trained by your vet or actually have the vet do it in case something goes wrong. So they use what's called an endoscope and a special lighted telescope, and literally just inject the semen directly in to those uterine horns. Takes about 2 to 5 minutes per female, depending on how good your person is. And conception rates this way are anywhere from 50 to 80%. So a lot higher. Does require a little bit more money because you are having that surgery done, but you get a little bit higher chance of having that conception. So at this point in time, we've got a film videoed by Todd Stroud of Hoofstock Genetics out of Texas that'll show you exactly what a laparoscopic surgery or artificial insemination is going to look like. So if you'd go ahead, Scott.
Here is a video from Hoofstock Genetics showing laparoscopic AI. Here we see where they are inserting a couple of metal tubes so they can see internally. This portion shows where they are inserting the tube for the camera so they can see inside to the uterus and uterine horn. This is the second tube that will be where the insemination gun will come through to inseminate the horns. This is the insemination gun, and you can see as they insert it into the first uterine horn to inject the first round of semen. They are now inserting it into the second uterine horn for a second round of semen. This just helps to ensure the success of the artificial insemination.
All right, so you can see in that video there how a laparoscopic procedure actually took place. It's kind of neat to be able to see in there and see them actually inserting that semen directly into that uterine horn.
Artificial insemination.
All right, so we can see here, these are going to show where the artificial insemination locations actually are depending on what type you're going to use. So we're looking at natural or that vaginal artificial insemination is just going to go right here. It's just going to go right into the anterior or the outside region of the vagina, just inside from the vulva. Our cervical is going to go right here. It's going to go right at where the vagina and the cervix meet, about one centimeter in, so not very far into that cervix. The transcervical, this is the one that's going all the way through the cervix and just into the body of that uterus. And then we have our laparoscopic or intrauterine, which is going directly into that uterine horn like we just saw. So we're looking again at our frozen versus fresh semen. Optimal time for insemination with non-frozen, so our fresh semen, is going to be about 12 to 18 hours after the onset of estrus. So this is where it helps to have that teaser buck available. So you can tell about 12 hours after she's in a standing heat is about when you're going to want to go for your fresh semen. If you're going to be doing frozen semen, especially if you're doing that out of season breeding where you're using the hormones, the CEDARs, you're going to want to do it about 48 to 58 hours after you remove that CEDAR for cervical or transcervical insemination. 48 to 60 hours later if you're going to go with the laparoscopic or intrauterine. And they have averaged about the highest conception rates is going to be about 53 to 54 hours. Now, if you pull the CEDAR, accidentally pull it a few hours early and it happens to be 1 or 2 a.m., it's okay if you miss a couple of hours, get a little bit of sleep, go out there at 4 or 5 and do it then. So when we're looking at pregnancy rates for artificial insemination with fresh versus frozen thawed semen, when you're looking at percentage of dose pregnant here on the bottom, fresh versus frozen, the solid orange is no cervical penetration. So we're looking at the vaginal or just barely the cervical. The orange or the yellow, gray is going to be the transcervical or the intrauterine. So we're looking at fresh semen. You're going to average about 40% conception with no cervical penetration when you're using fresh. You're going to have about another 29 to 30% if you actually have that cervical penetration. So you're up to about 70%. If you're using frozen thawed with no cervical, so you're just inserting it in there just barely, you're only going to have about a 15% conception rate. So not all that great. If you're actually putting the money and the time into this, make sure you're doing it properly and getting it in there into the cervix where it's actually going to count. You can see that has a great increase, especially when you're using the frozen thawed, up to about 60%. So last couple things here real quick to talk about is making sure you keep track of records. When you're looking at artificial insemination, you want to make sure you keep track of your records for every single insemination that takes place, whether it catches or not. So you want the AI date, so when it actually happened, what semen was used. If you put down the wrong semen, you might not be able to get it registered. Your sync protocol use, so was it a natural breeding or did you use some hormones? What were those hormones? What was the protocol that you used? Post-thaw examination, so if you do examine your semen after it's been thawed, what did you see? Time of the heat, so write that down. Semen deposition depth, so did you go vaginal, cervical, transcervical, laparoscopic? How far in did it go? Duration of the heat, so how long was that female in a standing heat? Was there any difficulty? Did you have problems getting through the cervix? Could you not find the cervix? What were some of those problems? And then estrus signs. So what were those signs of that female as she was going into that standing heat? So you can keep track and watch for those signs again 17 to 21 days later, depending on if it's sheep or goats, to see if the breeding actually caught, if you fertilized the egg, or if you need to try it again. And then just overall breeding records to keep track of. Sound reproductive management. Up until a couple years ago, my husband and I only kept track of kind of how many does or bucks were born. A few years ago, we started keeping track of birth weights, if there are any issues, things like that. So we got to figure out which of our bucks had the lower birth weights. So if we were using first-time fresheners, primarily 2-year-olds, which bucks were a little bit easier with those kittings to give birth. Instead of putting a buck that routinely will put 9-10 pound kids on the ground, ones that'll put 7-8 pound kids. A little bit easier on that doe. So looking at the birth date, any birthing difficulties, the birth weight, time of the kidding, you shall put morning or afternoon, who that doe was that gave birth, who the sire was, who the dam is, what the sex of that baby was, how many were born, if there were any stillborn, if there were any that were mummified, things like that to take into consideration. So all those things are really important to keep track of. So with that, I'd be happy to answer any questions that you guys might have. And if you need to reach me, I forgot to put this on here. My email address is eberry, so EBERRY at purdue.edu. Again, my email is EBERRY at purdue.edu.
Thank you, Alicia, for an informative talk. We are going to take about a 5-minute break so the viewing stations and anybody else that's viewing at home can put their questions in the chat box or send their questions to us, and then we will answer questions at that time. So it's about 7:58 Eastern time. So let's come back at about 8:05 Eastern time and answer questions. Thank you.
Okay, Scott, we have questions.
Okay.
Just so you know, Phil, we're getting your audio, but not Mike's.
What's the matter?
No, not right.
Okay, Alicia, here's a question. Does a doe ever run out of eggs, or does she only produce a certain amount over her lifetime?
Great question. So when that doe or that ewe is born, there's a certain amount of eggs that are already set in those ovaries. So once she releases all those eggs, she's done. There's literally hundreds of eggs in there though. So she could keep going. I think I've seen where 14, 15-year-old females, granted that's getting a little bit long in the tooth, but aged does can still produce. They may not have as long of a heat, so they may not release as many eggs once they get older, but it is still possible for them to reproduce at a much older age.
No. Okay, Mike. You test 1, 2, 3.
Test 1, 2, 3.
We can't hear Mike.
Okay, try again.
Test. Test 1, 2, 3.
How about now? Do it again.
Testing. Testing.
Again, we're able to hear Mike. I assume you are too, Alicia.
Yes.
She can hear you. Go.
Okay. Second question is, how common is it to have bucks with semen not good enough to use for artificial insemination?
That's a great question. I'm not 100% entirely sure on that. It just depends on the animal. Obviously, we have a lot of bucks or males out there that are breeding perfectly fine with semen, whether it's fresh or frozen. So it's really hard to tell unless those animals are actually evaluated, the semen's evaluated under the microscope. But if you're getting natural breedings that just are not taking year after year, that's what one of my other colleagues said, that she had a ram that this is the second year in the row he's been shooting blanks. So obviously I'd have him taken, get kind of collected or evaluated to see if he's actually viable. If not, he'd be going to the freezer. Maybe not mine, but somebody's. So definitely if you have a question if they're viable, I would definitely get them checked out.
Okay, another question, Alicia, is can frozen sheep or goat semen be purchased? How much does it cost?
Yep. So I did skip over that part. So frozen sheep and goat semen is definitely available out there on the market. There are several different companies out there that will basically store it or carry it for individuals. A few right off the top of my head, especially from the goat side, since that's what I'm familiar with, would be companies like Capragia, B&D Genetics down in Arkansas. There's a few others out there right now that I'm forgetting, but there's several that carry sheep as well, and they can cost anywhere from $10 a straw up to $500 a straw. It just depends on what animal is you're trying to get, the quality, how available it is. If that animal's been dead 20 years, obviously you're not going to be able to collect new semen. So there's a wide variety on that price. But when you look at the price of the semen overall, versus the price of a live buck, it's very affordable. Um, I watched the Newton sale. I think it was about 2 years ago. They're huge in the boar goat world. They were selling out of their stock. They had semen tanks available that they were selling the semen out of. You could average about $50 a semen straw on it. Granted, you were buying hundreds of straws at a time, but spending $50 on the straw versus their high selling buck, which was $26,000 or $30,000, there's a huge price difference there.
Okay, another question, Alicia, is how many AI breedings can you get from one ram or buck collection?
Yep. So normally when they do male collections, they usually like to try to get about 50 straws. So that's going to be about 50 breedings with a single collection. There's some out there that'll be overachievers where you might be able to get up to 100 straws. There's some where you may only be able to get 15 to 20. Again, it's just how much quantity you get from that collection of that buck.
Okay. Are there any workshops on how to do AI in goats?
Yep. So there's several out there. I myself hosted one. It'll be 2 years ago this coming fall. Um, Looking at potentially hosting another one here in the near future. Maybe not this year, but next year. But again, those companies that I referred to, Caprit Gia, B&D Genetics, I know they hold 1 to 2 day trainings where you get classroom and hands-on time to actually practice the transcervical AI. There's a bunch of YouTube videos out there. Make sure they're coming from educated resources, those that know what they're doing. But there's all sorts of different training options. I know different dairy goat associations, especially state ones, can offer some trainings as well. So just look in your state to see what's going on. Search for these semen companies to see if they're offering workshops in your area.
Make she's done.
Okay, this may be the last question. I'm not sure, Alicia, but for transcervical AI, is it better to synchronize a group of females or just to inseminate them as they come into heat naturally?
Yep. So that's certainly up to you. It depends on how closely you're going to be watching those females over the course of 21 days. If you'd like to do it on their natural cycle, obviously it's a little easier on them. You don't have to handle them as much. They aren't going to have those extra hormones going through their bodies. But if you have some huge event like your child wedding or something like that coming up, or a big, let's say your spouse has a family reunion you have to go to and you're not going to be able to be there to watch those females to see if they're coming into heat, then certainly syncing several of those does at the same time would be beneficial. You have that time management. You could watch them when they're synced. You know when they should be coming into heat versus just sitting there waiting for them to naturally come in.
Okay, thank you.
Thank you.
Thank you very much, Alicia. Really appreciate it. We're going to get up and going for the second presentation here just in a second.
So for those online, we're going to take a short break here of about 5 minutes, maybe 10 minutes, just to get the second speaker queued up.
All right. So will you need me anymore, Scott, or am I all set?
Here is a video from Hoofstock Genetics showing laparoscopic AI.
Our second presentation this evening will be given by Rusty Burgett. Thank you, Rusty, for taking time to present on this year's webinar. Rusty will discuss the topic using estimated breeding values from the National Sheep Improvement Program, the impact of genetic selection on flock productivity and profitability.
All right. Well, thank you for letting me join you this evening. I appreciate everyone's time. What we're going to talk about here this evening is record keeping and how it impacts genetic selection for sheep and goats. I think it's a great follow-up topic to our last presentation. I think the technologies of artificial insemination, it's a great way to breed lots of females to a select number of males, but we need to figure out which animals are going to make the most profitable or most productive joinings. So that's what where record keeping and genetic selection comes into play. So we're going to talk about the importance of record keeping, why it's an important practice we should implement in our operations. And then we'll talk about some of the nitty-gritty details, some techniques that we can use to make it an easier practice. And then we're going to talk about genetic evaluations. How do we put that information into practice to make some measurable change in our operations? So just to kind of get things started, record keeping is an important tool to make our flock and our herd improvements. There's the famous saying that you can't manage what you don't measure. So we have to be measuring things that we can actually implement in selection decisions to make a difference in our operations. And the things that we should be recording are things like animal productivity, which animals are being more productive than others, our financial management. Even if we're raising sheep and goats as a hobby, it's really nice when those hobbies pay for themselves, even make us a little bit of money. So financial management, herd health, and then animal traceability. And all of this record keeping, it's designed to improve our total productivity improvement in our U.S. sheep industry and our goat industries as well. I think it's always important to remember why we're doing the things that we're doing. And I think this graph here, along with a couple others, kind of illustrates that point. So those of us in the sheep industry, we're familiar with these statistics. This is sheep breeding inventory in the U.S., and it's been on a fairly steady decline. Okay. If we look at goat numbers, our goat numbers have been on the increase. Okay. But if we look at productivity out of our ewes, our productivity or our lamb crop out of our ewes mirrors that same downward trend in our numbers. Okay. So as we lose ewes or breeding animals in the U.S. sheep inventory, we lose lambs being produced by the same magnitude. If you look at pounds of product being produced off of these sheep, it kind of paints a little bit of a scary picture. So essentially what I did is I just took the inventory graph off those last two graphs that we had. So the inventory is in our blue line right here, and our red line is our pounds of lamb being produced from those ewes. And you can see that as we lose inventory in our U.S. sheep flock, we lose pounds of production by the same magnitude. Okay. What that tells me is that we're not getting much more efficient at producing lamb. If we were improving our production efficiency, we'd be able to produce more with less. So we'd be able to produce our red line should be on the increase, while our blue line is decreasing. If we look at the goat data, our goat inventory line goes up, but our pounds of production goes up by the same magnitude. We haven't seen improvements in production efficiency in our goats, just the same as we haven't in our sheep. If we were seeing productivity improvements in our animals, this is what those graphs would look like. Okay, this is a declining ewe inventory in the blue line and pounds of lamb being produced in this red line on top here. Okay, and this data right here doesn't come from U.S. producers. It comes from our colleagues across the pond over in Australia. Okay, and this is it's a little bit alarming to me, just in the fact that they are increasing their productivity, or they're becoming more efficient at producing lamb, and we're importing more and more of that lamb here into the United States. Okay, about 60% of the lamb being consumed right now is being produced overseas. Only about 40% is being produced domestically. So that tells me that we have a pretty good market share that we could be getting a hold of if we can improve our production efficiency. And the percentage of goat meat being consumed in the US is even higher than that 60% mark. We're importing a vast majority of that meat that's being consumed. Again, Australia is a large supplier of that product. Okay? So what we're trying to do with this record keeping system is we're trying to record animal performance data and economic traits, things that we can actually measure and make decisions on to improve our production efficiency. And that all starts with animal identification. Okay? If we don't know which animals are which, it kind of makes it hard for us to make selection decisions. There's a couple different ID types that we can be using. Most common are going to be our permanent identification, such as our ear tags. Most are going to have visual ear tags in them, ones that you can just get pre-printed or write on with a tag marker. We have scrapey tags that are available to us. RFID, or electronic identification, radio frequency ID tags are becoming more popular. Things like tattoos are permanent identification. We can do things like ear notching, not as common in our sheep and goat industries. We can also do temporary IDs, paint brands, paint markers, paint sticks, hang tags or neck tags, neck chains, that sort of thing. So obviously there's pros and cons. These permanent IDs, you actually have to apply those to the animals. So there's some animal welfare concerns we have to keep in mind there as we're doing those, make sure we're doing it in a safe and effective manner. Our temporary tags, though, they're just that, they're temporary. So these things are pretty easy to wash off. It's pretty easy to lose our neck tags and our hang tags. So personally, I prefer our permanent ID systems over here. Okay. So here's just a couple examples. Here's some scrapey tags. Unfortunately, these plastic tags will not be provided by the USDA APHIS for free anymore. You can get pre-printed scrapey tags up at your own cost. You can get these metal tags still available from APHIS. Here's a visual tag here, and these are electronic ID tags. So there's obviously a cost difference in our electronic ID tags, but I'll get into a little bit more detail as to how they can help us out, especially on our larger scale operations. Okay. So after we've got our animals ID'd, we need to figure out what data to collect, what information is going to be important to our selection decisions so that we can be making a difference in our productivity. So since we're looking to do genetic selection, pedigree information is going to become pretty important. Okay, so that's going to start off with recording the sire and dam of each of our animals. Okay, so we need to know where these lambs are coming from so we can make some genetic decisions. And then at our lambing or at our kidding times, it's important to record our type of birth and our type of rearing. So if they were born a single, twin, triplet, so on and so forth. And then certain phenotypic information like body weights at the birth time period, the weaning time period, even the post-weaning time period. And to some, I think adult weights would be, or a mature weight is going to be beneficial as well. Okay. So these are just simple phenotypic traits, or these are things that we can measure fairly easily. So we can do it on a nice fancy scale like this. This is a EID reading scale. There's actually a reader right over here where it scans an electronic ID tag of that animal. It goes on the scale. The weight gets recorded by the scale head right here automatically and sent off to a palm reader. Doesn't have to be near that complex. It can be a beam and balance scale. And I personally have weighed an awful lot of lambs by standing on a bathroom scale, zeroing it out, and then holding onto a lamb to see how much it weighs. So it can be as fancy or as simple as possible. It just has to be a repeatable measure so that every animal is being treated the same off the same equipment. So some other records we might be looking at is going to be our herd health records. I think these are going to be, these are extremely important when we're looking at some of those animals that are routinely giving us some problems. So I know from personal experience, I do think that our herds and our flocks kind of follow the 80-20 rule, that you spend about 80% of your time on 20% of your animals. So I think IDing those 20% is going to be important so that we can maybe think about putting them on the short list to be called at the end of the year. So things we might want to be recording will be our vaccination records, our deworming records. If we do treat something, we need to record what the drug was used, the amount given, the route and the location of that administration, and any withdrawal times. So this, I think, is one of the most important reasons to be recording our herd health, because we don't want to be unlawful in marketing some of our animals if they're still within a withdrawal time and haven't really reached that release date. Especially now with the new veterinary feed directive, this has become even more important. So these are things that we're going to need to work on with our feed suppliers and our veterinarians to make sure we're keeping track of which animals are being treated with those medicated feeds, and make sure we're adhering to any withdrawal times and maintaining those records just in case a problem were to arise later on. So after our production traits, those should all lead into our economic traits, because at the end of the day, if we're a commercial sheep or goat producer, we're in this to make some money. Okay? And even if we're a hobby producer, if making money, being profitable is not our number one goal, it's certainly nice when those hobbies pay for themselves. So I think all of our production traits should lead to an economic evaluation. Okay? So I think what we really need to be looking at is our cost of production. So what does it cost us to market a pound of weaned lamb or kid? What does it cost us to get a pound of our product out there onto the market? Okay? And to go into that cost of production calculation, we need to look at our input costs, our feed, our labor costs, vets, bedding, any of the different inputs that are going to cost us any sort of expenses, and then our revenue at the end of the year when we go to market those animals. So we can figure out a unit of revenue per unit of input on all of our animals. Okay? And these are going to vary from operation to operation, obviously. So we can do this on an individual basis. But I think this cost of production, what it costs us to market a pound of our product, should be at the forefront of most of our genetic selection decisions. So here's just a simple spreadsheet example of in order to calculate cost of production. Here's just this is a lamb feeding scenario with the number of lambs, how many lambs we expect to lose, the vet cost per head, the animal performance, average daily gain, feed intake, what it would cost for our feed. Then we can look at our revenue side, what it's going to cost, what it's going to cost to purchase those animals, what it cost per head, the total performance. Then we get into our revenue side, what we expect to make off of those lambs, what it costs to put on a pound of gain, and then what our potential profit and loss is on a whole herd basis and on an individual basis. Okay? So this can be pretty easily set up in an Excel spreadsheet. Again, it doesn't have to be this fancy. You can do it on a simple notebook. It can just be add up all of your expenses, add up all of your revenue at the end of the year, and divide one by the other. Okay? So we kind of have a decent grasp on what data we should be collecting now. We should be looking at these performance information matrix, things that we can actually be changing and implementing in our selection decisions. How do we keep track of all that information? Okay, is writing it down on the back of our glove going to be the most efficient way to do it? Most likely not. Okay, so there's a couple different ways we can do it. Simple paper records, electronic records with spreadsheets and databases, or becoming more and more popular now are these web-based or cloud-based computing tools. So we'll kind of get into these. I think paper records are the easiest, the cheapest by far. I think most of us keep one of these in our shirt pocket, just a simple yellow notebook. You can pick them up at any farm store, office supply store, simple write in the rain notebooks. It's very handy to have those on you. I know from, again, personal experience, if you have a big, bulky, let's say a clipboard or a notebook, most of the time when I need it, it's sitting on the dashboard of my pickup, not right here in my pocket where it's nice and handy to use out in the barn or out in the pasture when I need it. Okay? Some of the downfalls, though, is these paper records are not permanent. I have had many a record eaten by my animals. Even the animals on my records on my master's project got eaten on more than one occasion, which was interesting trying to write a thesis up later on about that. Okay, so they're easily lost and damaged. Okay. So I think it's important to have these paper records because they're easy to do. It's handy. You have a notebook on you when you need it, but we need to have a backup. And I think that's where electronic records, so like our spreadsheets and our databases, can be a good permanent backup for this information. So because they're definitely more secure than our paper, and they can handle large amounts of data efficiently. Um, it's always tough at the end of the year when you have to sort back through 50, 60 pages worth of notebook pages to try to get a good handle on your total productivity for the year. So getting into an electronic format can be handy for sorting through all that data. So there is a little bit of a learning curve, though, to some of these programs, such as Excel. If you're not familiar with Excel, spreadsheets can be a little intimidating to some, especially some of those that have maybe been raising sheep and goats for longer than others that didn't grow up with computers. It can be a little difficult, but there's lots of great tutorials out there. There's videos, there's classes. Most of your community colleges will have classes on that sort of thing. And another problem is data overload can actually be an issue. We can start to get into too much data and not figure out or not know how to handle all that information. We'll look at an example here. This is just an example spreadsheet. This one happens to go out about 120 columns wide. So it can be a little difficult. You can get into some pretty serious data overload. So I think we need to look at efficiency in collecting the right data, the data that's really going to have an impact on our bottom line. And then if we take it one step further in the technology sector, is we move to a cloud-based or mobile software program rather than a stationary program like our spreadsheets. So I'll take a step back real quick on our spreadsheets. Again, everyone has one of these in their pocket as well, a smartphone or a cell phone. So with a lot of our cloud-based data management systems now, things like Dropbox and OneNote, things like that, you can actually get Excel to put on your iPhone or your Android device, and you can keep these spreadsheets on your cell phone as well. Okay? But if we want to step it up again, we move up to our cloud-based or our app programs. These are commercially available software programs or apps. Some of them are available for free. Other ones have a subscription tied to them. These can get pretty intense on our and beneficial in being able to record day-to-day management information. So you can keep track of things like your treatment records or pasture rotations, things like that, vaccination records. One of the limitations, though, to these is getting all of your data back out of that system. Some of the reporting functions are not very customizable. They'll come with stock reports, so they'll tell you the productivity of a U or the productivity of an entire group. But if you want to customize that report and have it tell you exactly what you want it, some of those are a little bit limited in their reporting functions. Okay. As I said before, some of them are available for free. Some of them do come with a subscription fee attached to them. And I've seen fees anywhere from $20 a year up to $1,000 a year. And they are one thing that you kind of get what you pay for on these. So I think as you get into the more robust cloud-based systems, the more that's going to cost you on a yearly basis. And one other potential drawback is I don't know how many people out there, how many internet hackers would be interested in sheep and goat production data, but that might be something to think about for the future is data security. I don't think there's any online platforms that are immune to data breaches. And right now, it might not be that big of an issue, but say there was ever, God forbid, a disease outbreak, or if we get into DNA testing, we've come up with some genetic susceptibilities to certain traits. We might not want that information broadcast out there to the entire world. Okay, so we might need to look at some data security options. So here's just a couple of examples of these. There's the Herd Boss is one of an app that is available. I believe that one's free. There's some other ones here, like the FarmWorks program that's offered through Shearwell. That one does come with a subscription, but I do believe it is it's more robust than the free versions that are out there. So lots of different platforms, lots of different tools that are out there. Doing a simple Google search can help you pull up a lot of those, which ones are available, and you can look at some reviews, figure out which ones might be right for your operation. Okay. So we've kind of talked about what data to collect. And we've also kind of looked at ways to manage that data. Now we need to look at how do we implement this data into our selection decisions. So we need to look at data utilization. So we need to implement this information somehow into our decision making in order to make a difference, in order to improve our production efficiency. So how do we compare information, or how do we compare two animals to do that as in the most informed way possible? And this is kind of the danger of raw data is what I call it. So we'll look at two examples here, two lambs that we're looking at as potential replacements. We have lamb A and lamb B here. Lamb A weighed 62 pounds at weaning time, and lamb B weighed 75 pounds at weaning time. So in order for us to make an informed genetic selection decision, we need to figure out, why was this one heavier, and is it truly better than this animal right here? Okay. And if you're a goat producer, I apologize. You can think of these as kid A and kid B, and we can go on about that just like that. So what we're trying to do here is we need to compare apples to apples. So we need to figure out a way to standardize our data, make sure that they're on an even playing field, and we're comparing or making a fair, accurate comparison. So in our weaning weight example, there's a lot of different things that can lead to this difference in our weaning weights. So things like the age of the lamb. Maybe that lamb B is simply an older lamb. Okay. Maybe that lamb B had a higher birth weight, so he had a higher starting off point and didn't have as much weight to gain to get to that larger weight. We also need to look at our birth type and our rearing type, because we know that as birth type increases, those lambs or kids have to compete with their siblings for groceries when they're trying to nurse on mom. So they're at a little bit of a disadvantage when it comes to average daily gain. We also have to look at the age of the dam. We know that our really young dams and our really old dams are at a little bit of a disadvantage when it comes to milk production. And also simple biological differences like gender. Okay, we know that our intact males are going to be growing faster than our castrated males, which are going to be growing a little bit faster than our females. Okay? So we need to take all those things into consideration. So we'll go through a little bit of an example here on how to do some of this algebra. Okay, I'm sure algebra was everyone's favorite subject back in school. So we'll walk through this and try to go through it pretty easily. So we have our lamb A here, and he weaned at 62 pounds, had a birth weight of 10 pounds. Okay, so he started off at 10 pounds. So from 10 to 62 pounds, we know that this lamb put on 52 pounds. Okay, and this lamb is 60 days old, so it put on 52 pounds in 60 days. Okay, so if we take our 52 pounds by 60 days, we can figure out that they had an average daily gain of 0.87 pounds per day. Okay, so if we want to standardize this for age or correct it for age, we knew that it grew for, we want to standardize to 60 days. We knew that it grew 0.87 pounds per day, standardize it to 60 days, plus its birth weight that it started out at, we get an age-corrected weaning weight of 62.2 pounds. Conversely, if we look at lamb B here, it was 75 pounds, okay, but it was 14 pounds at birth, and it was 10 days older at 70 days. Okay. Again, we can figure out our average daily gain, figure out the amount of weight that was gained in the amount of days that it took to get there. They have a similar average daily gain of 0.87 pounds per day. If I want to put this on the same playing field as lamb A, I want to standardize it to 60 days. We take that average daily gain of 0.87 times the days of age plus its birth weight, and we figure out that it has an age-corrected weaning weight of 66.2 pounds. Okay? So lamb A and lamb B aren't as different when we correct for that 10 extra days of age. Okay? Lamb B still has a little bit of an advantage there of about 4 pounds. Okay? So of that 4 pounds, okay, what else could be impacting that rather than just age? Okay? So we need to look at taking it another step further. We did our age-corrected weaning weight. Now we need to adjust for things like the age of the dam, the sex of the lamb, and the type of birth and type of rearing of that lamb. Okay, so this is it's a busy table. I apologize for that, but you can find this. This is in the Sheep Production Handbook, the SID Sheep Production Handbook. You can also find it if you just go to Google and type in adjusted weaning weights of lambs or adjusted weaning weights of kids. You can find this information. So what we have here is our dam age category, the gender of those animals, and the type of birth, type of rearing. Okay, here's are the available classes within those categories and the adjustment factors, okay, that go along with each of those. So if we have a lamb that's being raised by a 2-year-old ewe, we're going to adjust that weaning weight by a factor of 1.08. And if we're comparing a wether to a ewe, that wether is going to be adjusted down by 0.97. Okay, now I'll go through an example of this. Okay, so again, we have lamb A, and he weaned at 62 pounds. Okay, we had our age corrected weaning weight of 62.2 pounds. But we now see that this lamb was raised by a 2-year-old ewe. It's a ewe lamb, and it was born a twin, raised a twin. Okay, so if you look back to our table here, we have it's a ewe lamb that's being raised by a 2-year-old ewe. Okay, the age of the ewe. We see that it's a ewe lamb, so we have a 1.0, and it is a twin-born, twin-raised lamb. We're going to adjust by 1.21. We take those adjustment factors. We have our age correction, age of dam correction, our gender correction, and our birth type, rear type correction. We come up with an 81.3 pounds adjusted weaning weight. So that's a big difference from that 62.2. Okay. If you look over here at lamb B, again, he was at 75 pounds, age corrected to 66.2, raised by a 4-year-old ewe. And this is an intact ram who was born a single, raised a single. We see that his adjusted weaning weight goes down quite a bit to 68.25 compared to our lamb A. Okay. So now we have these lambs on a fairly even playing field, and we can see if we're looking to make selection decisions, I'm more interested in this one right over here at lamb A rather than this one over here at lamb B. I'd much rather have 2 lambs over here at this side than have just 1 lamb at 68.25 pounds. Okay. So this gets into the NSIP portion of our talk then. So we have this big difference in our adjusted weaning weights, but how much of that is controlled by genetics versus how much is controlled by environment? Because there's a lot of other environmental factors in this that aren't being taken into consideration. Okay. So if we look at any animal that we're looking at, in general, 80% of what we see or what we measure is due to the environment that that animal was raised in. Okay. But if we're looking at breeding animals, it's this 20% that we can't see that's controlled by genetics. Okay? That's the part that gets passed on to the next generation. Okay? If he's a breeding ram, he doesn't pass on all this environment that we see. He passes on that 20% that's controlled by genetics that makes up our next crop of ewe lambs or our next crop of doe kids. Okay? And it varies from trait to trait. So some traits are highly heritable. They're highly controlled by genetics. Things like our growth traits, our carcass traits, wool traits, and our fleece animals. Okay, those are highly heritable traits. And we can make decent progress in those traits by visual appraisal and by our raw data. But things that are a little bit more economically important, things like our reproductive traits, okay, these are lowly heritable traits. That means that if this ram here, if he was born a twin, raised a twin, 90% of the fact that he was born a twin is due to how well his dam was fed, what type of environment that dam was raised in. Okay, it's that 10% that you can't see that gets passed on to the next generation. That's what makes up the next crop of ewe lambs. That's the part that we need to try to quantify and make an educated selection decision based on. Okay, all this environmental stuff just kind of clouds our vision. Okay, but even though this is lowly heritable, even though this is 10%, that doesn't mean it's less important. Okay, if they don't have this 10%, this part that's controlled by genetics, that genetic potential, if they don't have that, it doesn't matter how well you feed them, they're never going to outperform that genetic potential. One of my old mentors used to tell me that you can't feed your way out of poor genetics, but you can starve yourselves out of good ones. And that tells me that they can have the greatest genetic potential in the world, But if you don't feed them, they're never going to perform to that genetic potential. And on the other side, though, if they don't have that genetic potential, you can tie a bucket of corn around their neck and they're never going to outperform what those genes tell them they're supposed to do. Okay. So this is where NSIP comes in, okay? Because we know that every single animal here is a product of both its genetics and its environment. And when we're looking at an animal trying to make a selection decision, we see mostly this. But this is what's get passed on. This is what we need to try to quantify. So we eliminate the environmental differences and we quantify this genetic difference right here. We do that through these tools called estimated breeding values, or EBVs. So EBVs are tools that minimize the guesswork around selection or buck selection. And they do that by assigning a number value to the genetic merit of that breeding animal. Okay? And that allows for quick and easy comparisons because it has a number value attached to the genetic merit of that animal. And they're an extremely powerful statistic. They're more powerful than adjusted means that we just walked through. And I'll show you kind of where that power comes from. Okay? I apologize if you hear that. I've got a hypothermic lamb on the ground in a box next to me that's starting to wake up a little bit and get some life back in them. So that's good. So, all right, so these estimated breeding values, where do they come from? Okay? So we start by measuring phenotypic traits of animals. Okay? So phenotypic traits, just like we were talking about in our record keeping, those are things like body weights, carcass measurements, reproductive traits, and our wool traits. Okay? And this is where the power of NSIP comes in, because producers, you collect that information on your farm or on your ranch, submit that data to NSIP for analysis, and then we start to build the power into these statistics. So we have an individual lamb here, okay, and he was raised in a contemporary group, or he was raised with a bunch of contemporaries in a similar environment. So we have a decent estimate of his genetic potential. Okay, if lambs are raised in a similar environment, or kids are raised in a similar environment, we can estimate that any differences are going to be due to genetics. But we're not just happy with that. We know that this lamb or this kid got his genetics from somewhere. Theoretically, he got half of them from his sire, half of them from his dam. Okay, so if we're looking at a trait such as weaning weight, okay, we know that he got half of his genetics for weaning weight from his sire, half from his dam. So what we do is we take the weaning performance of his sire back at weaning time and that of his dam and use it to adjust the estimated breeding value of our individual in question. Okay. Take it another step. We say this lamb was born a twin, raised a twin, so he's got a full sibling over here. Okay, so we know that they share common ancestors, the same sire and dam. That means that they have genes in common. Okay, if they have genes in common, there's a good chance that their genes for weaning weight are similar. So we're going to take his performance at weaning time and use it to adjust the EBVs of our individual in question. And let's say he's got a bunch of half sibs over here. Okay, they have the same sire. That means they have genes in common. We utilize all their performance information in his EBV calculations. And let's say he's got a third cousin twice removed on a farm that's 6 states away. Okay, doesn't matter how far away they are geographically. If they have ancestors in common, that means that they have genes in common. So I want to look at his performance information and see how it impacts the genetic potential of an individual in question. Okay. So we take an animal's individual performance, compare him to all of its contemporaries, standardize for environment, compare them to every single known relative in the system, including relatives in other flocks and other herds. Again, doesn't matter how far geographically, it can be on the other side of the country. If they have genes in common, we're going to take that information into consideration. Then we're going to adjust for things like genetic relationships, genetic correlations and antagonisms, heritabilities, all that good stuff. Okay? So you can see that we take a lot of information into these genetic predictions, okay? A lot more than just those adjusted weaning weights. And what we end up with after we do all that math is this right here. And this is a panel of estimated breeding values. So we have an ID number for a breeding ram, and these are all the estimated breeding values for that ram. So if you look at an example here, all these abbreviations, they all start with an age category and a measurement type. Okay, so if we're looking at weaning weight, W stands for weaning, WT stands for weight. And this ram, for example, has a 3.0 estimated breeding value for weaning weight. And what that tells me is that this ram has the genetic potential to be 3 kilograms heavier at weaning time than that breed. Okay? He has the genetic potential to be 3 kilograms heavier than weaning time. So another way to look at that is if he has a 3.0 and I have another ram over here who's got a 1.0, I would expect this guy to be 2 kilograms heavier than the one over here with the 1.0, okay, at weaning time. So this is an estimated breeding value. This is what the individual in question's genetic potential is. But I'm interested in him as a breeding animal. I want to know what his lambs or his kids are going to do. So if this ram or this buck goes out and sires lambs or kids, those lambs, they inherit half their genes from their sire. Okay? So essentially all I do is I take this number right here, this 3.0. If I want to know what his lambs are going to do, I divide it by 2. So I'd expect his lambs to be 1.5 kilograms heavier. Okay. One more step of algebra for you, and then I promise we're done. Okay. I said this is reported in kilograms. Okay. Since we're one of 3 countries in the world that doesn't use the metric system, let's put this back in terms of pounds. Okay. I'm definitely used to thinking in terms of pounds. If we convert pounds to kilograms, it's 2.2 pounds per kilogram. I just divided this number by 2 to figure out what his lambs are going to do. I multiply that by 2.2. Essentially, you can forget about all that algebra. This is what we expect his lambs to do in terms of pounds. I'd expect lambs out of this ram to be 3 pounds heavier at weaning time. Okay, so that's a weaning weight example. There's all sorts of different traits available. So that's a weaning weight. PWWT stands for post-weaning weight. So this ram, for example, would sire lambs that have the genetic potential to be 4.5 pounds heavier at the post-weaning time period. Look at carcass measurements, like this is yearling eye muscle depth. Okay, we'd expect lambs out of them to have a 1.6 deeper loin eye. This is a fine wool sheep, so things like yearling grease fleece weight, we'd expect his daughters to shear a 23% greater grease fleece weight than the average of that breed. Okay, so what traits are available? We have EBVs for our weight traits, so we can get what the genetic potential is for birth weight, weaning weights, post-weaning, yearling, and adult or mature weights. We can do the genetic potential for carcass traits like eye muscle and fat deposition. For our fiber animals, we look at fleece traits. There's a list of fleece traits that's as long as your arm. There's grease fleece weight, clean fleece, fiber diameter, staple length, staple strength, so on and so forth. For our commercial producers, I think our reproductive traits are our most important, our number of lambs born and our number of lambs weaned. I think that's where we have the most potential for productivity improvement in our U.S. sheep industry. The U.S. sheep industry, we have an average lamb crop nationwide of 111%, which for us Midwestern producers, most of us would think that that's pretty sorry. Okay, so I think our number of lambs born and our number of lambs weaned genetic potentials are going to be pretty important. And I think this one right here, fecal egg counts, is going to become a more and more important estimated breeding value. So what fecal egg count does is it estimates the genetic potential for internal parasite resistance. Okay? The truth of the matter is that our dewormers are becoming less and less effective every year. We're getting anthelmintic resistance. We're probably not going to get many new dewormers coming into our industries. So we might need to look at other ways to combat internal parasites. And we know that there's differences in genetic susceptibility to internal parasites. So I think using these tools of estimated breeding values is going to become more and more important. Okay, so this chart here is going to be a little bit busy. This just quantifies the data that I just presented. So all we have here is we have age categories, we have the age ranges associated with those categories, and then measurement types across the top here. So if a cell has the word yes in it, that means that age category measurement type has an estimated breeding value available to it. So if you're interested in post-weaning scrotal circumference, there's an EBV for that. Or if you want to know the parasite resistance at the yearling time period, there's an EBV for that. Okay? This doesn't mean that if you sign up for NSIP that you have to collect all this information. Okay, there's no measurements that are mandatory in NSIP. You don't have to sit there and weigh your sheep every 30 days or weigh your kids every 30 days to be a member of NSIP. What I always try to advise people is you'll collect the information that's important to your flock or your herd economically, or what's going to be important to any of the buyers of your genetics. Okay. So I'll just go through a couple quick examples of does this technology actually work? Okay. So just a quick reminder, when the rest of the US sheep industry is doing this, okay, we're not really getting any better at producing pounds of lamb nationwide. Some of our producers in NSIP have seen some pretty different results. Okay, so over the last 10 years, the average Targhee breeder in NSIP has been able to add 9% to their number of lambs born. So they're dropping 9% more lambs. And this is just based on genetic selection. So just based on which rams they put out there, they've been able to increase their number of lambs born by 9%. And it's not just good enough that they're dropping more lambs, those lambs are also faster growing. So they've been able to add about 2¼ pounds to their weaning weight, which is in this blue line here. And in the red line, they're also getting an additional 2¼ pounds based on maternal weaning weight, or they're being raised by better moms, better dams that are have better maternal ability, producing more milk, and keeping those lambs fast and growing. So they're getting additional 2¼ pounds because of their own genetic potential, and then another 2¼ pounds to weaning weight based on their dams production, while also increasing their grease fleece weight by 8% while maintaining fiber diameter. So if any of you have ever selected for wool traits, you know that these are positively correlated traits, but in a negative way. In general, as you increase grease fleece weight, you also increase fiber diameter, which we don't want to do. We want to maintain fiber diameter or decrease it a little bit. By selecting based on estimated breeding values, the Targhee breeders were able to figure out which rams were outliers, which ones could shear a higher fleece while maintaining fiber diameter. Okay? So our breed as a whole was able to do this. So if we do some back of the envelope math, look at the increases in number of lambs born, increases in weaning weight, maternal weaning weight, and fleece weight, the average Targhee flock on NSIP now is marketing 13 pounds more product than they were 10 years prior. If you look at another breed, the Polypays, this is a breed that's near and dear to my heart because that's what I raise. The average Polypay flock in NSIP has been able to add, has been able to increase their number of lambs born by 12%, and increase their number of lambs weaned by 15%. Okay, so that means that they're selecting for better mothers and not losing as many lambs. Okay, but able to increase the number of lambs born, but also keep more of those lambs alive, while also increasing weaning weight and increasing the mothering ability of those dams. Okay. So if we do some similar back of the envelope math, looking at the increases in number of lambs weaned, weaning weight, and the milk production of those dams, the average Polypay flock is marketing 16 pounds more lamb than they were 10 years ago, just based on genetic selection alone. And I think that really illustrates the power of these tools, because that's just based on genetic selection. That's not increasing nutrition, not changing seasonality or anything like that, just based on genetic selection alone. So I'll kind of speed up here just to keep us on track for time-wise. If you look at the terminal sires, our terminal sires have seen similar increases in our growth potential for weaning weight and post-weaning growth potential, while also increasing eye muscle and decreasing fat deposition. And these is another interesting set of data because these are generally negatively correlated traits. Generally, the faster you're growing, faster growing lambs are generally going to be our wider muscled animals. Think of purebred frame type sheep versus our weather type sheep. Our purebred frame type sheep are generally faster growing, but they're not going to be nearly as heavily muscled as our weather types. And conversely, our heavy muscled weather type sheep are going to be on average slower growing. But again, by selecting based on these tools, our Suffolk breeders are able to add both growth and eye muscle at the same time. Find those outliers that can do both. Okay. If you look at some of our Katahdins, our hair sheep, we've seen similar increases in our number of lambs born, number of lambs weaned, also increasing our weaning weight and mothering ability. And this one I think is the most important in our catodons, to be able to increase our parasite resistance. So fecal egg counts is a number that we want to be low. We want a low or a negative EBV on that one. So being able to see increases in productivity while also increasing genetic resistant internal parasites. And if you add those things up to our catodon U output, our average catodons are now marketing 10 pounds more lamb over a 10-year time period. And that's not factoring in the benefits of increased parasite resistance there. Okay. So imagine if you could also take advantage of our heterosis in our populations. If we could take a Targhee ram who's been bred for 9% more lambs born, breed it to a Polypay ewe who's been bred for 15% more lambs weaned, take those F1 crosses and breed them to a Suffolk who's been selected for this type of growth, that's how we can start to see some differences in our productivity and our production efficiency. Okay. And I just presented some sheep data here, but there's absolutely no reason why this technology can't be utilized in goats. We do have goats that participate in NSIP, and our individual herds have seen some pretty similar increases in our productivity. Okay. So I'll just go through a commercial example of utilizing this information. There's a commercial range ewe operation from central Utah. In their 2016 lambing season, they wanted to test this out. They wanted to test out the NSIP EBVs to figure out if it was going to work. So they took one of their bands of ewes and they split that band in half. And they bred half of that band of ewes to Suffolks that they bought from NSIP flocks that had been selected for growth. And they bred the other half to Suffolks that they bought up conventionally, just through how they've always been buying rams for the last however many years. Okay? So there's about 550 ewes per group. It took about 17 rams per group to get those ewes covered. They were managed as one band before and after breeding. All they did is when they came in the fall for breeding time, is they split the herd in half. They just ran 20 ewes to the left, 20 ewes to the right, 20 to the left, 20 to the right, and they paint branded them different colors. So all the ewes that were bred to NSIP rams are paint branded one color. All the ewes to the other rams are paint branded another color. When those ewes lambed, those lambs got an ear tag that matched their ewes paint brand color. They shed lambed all their multiples. They range lambed all their singles. This is about what their situation looked like. This is what their alfalfa ranges looked like for their lambing time, commingling time. Okay. When those lambs were shipped, all of the lambs from NSIP sires went on one truck, all the lambs from the conventional sires went onto another truck, and they were all raised. Okay, so they were grazed as one big band after lambing time. They're sorted off at weaning time, so they had a similar environment, and they found that the lambs from conventional sires averaged 102 pounds at weaning time, but the lambs from the NSIP sires averaged 105 pounds. There's a 3-pound advantage to those NSIP sired lambs. If we just do some quick dirty math, if we put a value of $1.44 per pound of that lamb, each lamb was worth an additional $4.32. Okay, so each ram that was used, each of those 17 rams brought in an additional $100 in revenue to that flock, just because they were purchased on the EBVs that they knew were going to make an impact on their operation. Okay, so if we think about if those lambs averaged 3 pounds heavier than the other lambs, what do we think the average EBV was of those NSIP Suffolks for weaning weight? Well, the average 3 pounds heavier, the average EBV was 3.3 pounds. Okay, so those lambs performed exactly what their estimated breeding value said they were going to do. Okay, if we look at what the current breed average is of NSIP Suffolks, the current breed average for weaning weight is 4.25 pounds. So the average Suffolk ram in NSIP now was predicted to wean lambs that are 4.25 pounds heavier. Okay, so we've made a little bit of progress compared to where these lambs were back in 2016, and this hopefully proves a point that just because a ram or an animal is on NSIP or has NSIP records doesn't mean that it's a better animal. Okay, they have to have the right EBVs or the right values to increase productivity to our flocks. Okay, if these animals had negative weaning weight EBVs, we would see the reverse trend. Okay, those lambs would be lighter than those average rams. Okay. All that being said, EBVs are a tremendously powerful tool. It's not a silver bullet. It's never going to replace visual appraisal of a ram or a buck. Okay, we still have to look at those animals, still have to be sound on their feet and legs, free of foot rot, free of foot problems, have to have a good mouth structure, pass a breeding soundness exam, and we still have to test for certain health statuses and health susceptibilities, things like scrapie syndrome, OPP, spider lambs, CAE, yonis. We still have to test for these sorts of health statuses and susceptibilities. Okay, I don't care how good of a number a ram or a buck has. If he doesn't have good sound feet and legs, can't get out there and cover country, cover ewes or cover does, he still needs to go to town. Okay, if he's he can be in the top 1% of the breed, but if he's parrot mouthed and pigeon toed and only has one testicle, he needs to go down the road. Okay, it shouldn't be used as a breeding animal. Okay, doesn't replace good management protocols. Okay, we still have to provide these animals with a good environment to express these genetic potentials. Still have to have a good breeding program, including crossbreeding. I think this is the most underutilized technology in our sheep and our goat industries. We're giving up free productivity through heterosis there in our commercial production systems. Okay, we can also look at increasing our use of artificial insemination to get the right genes into the right dose. Still have to have the right good nutrition programs. Still have to have good sound marketing programs. Okay, all these genetic potentials don't replace any of this. Okay, so just to wrap things up, utilizing EBVs in our breeding selection decisions is designed to reduce the risk associated with ram selection. Okay, you don't just have to flip a coin and guess whether a ram or a buck is going to be a good breeder. Okay, you have a good, a quantified genetic potential for all those animals. And because of that, we can expedite our genetic progress and increase our productivity. Okay, so just with that, I'll wrap things up. I need to say thank you to the American Sheep Industry Association, National Sheep Industry Improvement Center, and the American Lamb Board. They've all rallied behind NSIP to help get this tool out there to the sheep and goat industries. If you want some more information, you can go to our website, which is nsip.org. My email is info@nsip.org, and that's my phone number right there. I'd be glad to take any questions from you afterwards. You can also look at our Facebook page, and we also have a YouTube channel as well that has some flock highlight videos and some tutorial videos on how to use the information. So with that, I will wrap things up, and I'll take any questions that you might have.
Okay, thanks, Rusty. We have a couple questions, and I'm sure there'll be more come in. We're running a little over time, but like to get the questions answered if we can. One question is what traits are best to select for if you are a small producer? I guess that'd be your sheep or goats.
Yeah, so what traits are best to select for a smaller producer? So for the vast majority of sheep producers in the US, and goat producers will be the exact same thing. The number one determinant of profitability in terms of our production traits is going to be pounds of lamb weaned per ewe exposed, okay? Or pounds of kid marketed per doe exposed. Okay, so what kind of goes into those factors? Well, first, number of lambs born and number of lambs weaned. Okay, so these females have to get bred, and they have to have lambs or kids, and they have to keep them alive. So it's not just good to have a high number of lambs born or number of lambs weaned. You also have to look at the growth potential of those animals. Okay, so they have to hit the ground. They have to be wide enough at birth that we don't have dystocia problems. They have to be heavy enough at birth that we don't have survival problems. Okay, so the big things that I would look at would be number of lambs born, number of lambs weaned, and then our weaning weight and post-weaning weight. I think those are the traits that are impact our profitability or productivity the most.
Okay, so is that my, okay, what breeds use NSIP the most?
Okay, so yeah, NSIP is open to any of our sheep and goat breeds. The vast majority of our records are on sheep, but again, it's everything we have available to sheep is available to goats as well. Our largest breed on NSIP is Katahdins in terms of numbers of flocks. So we have more Katahdin flocks. They actually make up about 25% of our total NSIP membership. In terms of numbers of animals, Targees are our largest breed in terms of numbers of animals. That's mainly because most of our Targees are raised out in our Western Range operations, and they're larger scale operations. So again, it's open to any breed. We've got everything from Katahdins to Polypays are our big kind of our commercial ewe in the Midwestern area. Ramblays and Targees are the Western United States. Terminal sires are mostly our Suffolks and our Hampshires. Then we've got more of our rare or heritage breeds. We've got Black Welsh Mountain Sheep, and we've got some Icelandics and some Shetlands. We've got everything in between. On the goat side, we've got kind of main commercial goats, some Spanish goats, and Kikos are our other large breed, a handful of boar goats. We don't have any dairy modules set up right now for our dairy goat producers, but the dairy goat producers, they can get very similar information to DHIA.
Okay, last question I think that we have for the evening is it expensive to be on the NSIP program, or what does it cost to be on the NSIP program?
Sure. So yeah, I had that slide in here, but I took it out just to try to save on a little bit of time. Okay, so there is a cost to be involved with NSIP. And the way that we kind of have it structured is that I don't expect every flock or every herd to enroll in NSIP in the U.S. We really have it geared towards our purebred, our seed stock provider. We really try to encourage them to join NSIP, and hopefully be selling breeding stock to commercial producers, preferably at a premium. So what it costs to enroll in NSIP is it costs $100 per flock or herd, plus $2.50 per breeding animal that you expect to lamb out or kid out that year. So for our average flock in NSIP, or average herd, it costs about $250 to be a member. We do have some discounts and some caps on those fees, so we try not to penalize our really large flocks. And we also have for our first year, for all new members, we waive that membership fee. So all you have to pay is that per animal fee for the first year. You can try it out for a minimal investment to see if it's something that you'd like to look at. So you can actually go to our website, nsip.org, and you can look at there's a section that says Become a Member, and it takes you to an enrollment form, which breaks down the fee structure. You can see what it would cost you to become a member.
Let's stop moving.
Very good. Okay, that's all we have for questions. Thank you very much. I see a very informative talk. I really appreciate you taking time to do it, and I hope your lamb makes it. To the viewers out there, I'll remind you one more time, we really would appreciate if you would do the evaluations, because we do use those in a number of ways, but one way we really use them is to try to plan future years' webinars. Thank you for joining. Hope you learned something tonight. Thank you very much.